The FPGA design flow is shown in the figure below. As shown in the figure, the initial step in the process is the description of the logic circuit. This can be done using schematic capture tool or using Boolean expressions. This step is followed by a translation that converts the original circuit description into a standard format used by the CAD tool. The circuit is then passed through the CAD programs that initially partition it into appropriate logic blocks, then select a specific location in the FPGA for each logic and forms the required interconnections. The performance of the implemented circuits can then be checked and its functionality can be verified. Finally, a bitmap is generated, and this can be downloaded into the FPGA in a serial fashion to configure it. Initial design entry. The description of the logic circuit can be entered using a schematic capture program or using Boolean expression. The available building blocks are taken from a component library. The description of the logic circuit can be entered either using a schematic capture program as in Cortex Prime or by using a behavioral program to describe the Boolean expression as in Xilinx ISE software. Translation to .xnf format. After the logic circuit has been fully designed and merged into one circuit, it is translated into a special format that is understood by the CAD tool. This format is called as the .xnf format. Partition or technology mapping. The SNF circuitry is next partitioned into Xilinx logic cells, but more common terms for this step is technology mapping. Technology mapping converts the XNF circuit, which is a netlist of basic logic gates, into a netlist of Xilinx logic cells. The logic cells used depends on which Xilinx product the circuit is to be implemented in. Place and route. This step can be done automatically by CAD tools, manually by the user, or a mixture of the two. The first step is placement, in which each logic cell generated during the partitioning step is assigned to a specific location in FPGA. Following placement, the required interconnections among the logic cells must be realized by FPGA's interconnection resources. After the logic circuit is fully designed and merged into one circuit, it is translated into a netlist of basic logic gates. Then it is mapped to a netlist of Xilinx logic cell. Then placement and routing is done. Performance calculation and design verification. Once the circuit is routed, the physical paths of all signals within the FPGA are known. It is therefore possible to check the performance of the implementation. This can be done by either downloading the configuration bits into the FPGA or by using an interface to a timing simulation program. If the performance or functionality of a circuit is not acceptable, it will be necessary to go back to modify the design at some point in the design flow. Once the timing and functionality is verified, the circuit implementation is complete. The performance calculation and design verification can be done by using an interface to a timing simulation program such as Model Sim. Performance calculation and design verification can also be done by downloading the configuration bits into the FPGA and checking the part within its circuit board.